This is a view of the office at Milpo's El Porvenir mine, located near Cerro de Pasco in Peru. And just a view, guard house, and down this way I've see the mill. That's where you can see some of the mineral coming off a conveyor belt, coming out of the mine, that gets processed in the mill. Mineral is then shipped out as concentrate, and most of that concentrate apparently goes to Europe and is copper, lead, and zinc. That's the opening to the mine, and as is typical in Peru, most of the head frames or the hoists are not located above ground, they're located in the mountain. The walk to the hoist room is perhaps half a kilometer. And at this mine we have field controls on a 3,000 horsepower production hoist. The hoist is powered from a 3,000 horsepower synchronous motor and generator. Our controls have been here for perhaps 10 years. There's two sets of field controls, one for the primary use and a second set for backup. As is typical with the mines in Peru, the accommodation is on site. They call it a motel, so you might be sharing a room with 2 or 3 other individuals, and there's a mess hall, or they call it a commodore. Milpo is located at an altitude of about 4,400 meters. Any of the electrical equipment that's supplied to the mine has to have a derating factor because the air is thinner and doesn't have the same cooling effect that it would have at sea level. The production hoist is down this tunnel right here, and that's where we'll be going next. The service hoist is located down this tunnel. We've just received an order for 1,200 horsepower AC package, transformer, drives, and motor for a replacement service hoist, which should be installed in January or February of 2009. This is a view of the 4,000 horsepower DC motor that drives the hoist, and beside it we can see the 2 drums. This is a dual drum hoist. One conveyance goes down and the other one's coming up at the same time. And right now they're doing some maintenance on the bull gear, and we can see over here that the cover is off the bull gear and some alignment is being done. On this side we see the 3,000 horsepower MG set that supplies the power for the hoist motor. This is the DC generator and synchronous motors on the other side. They've just had some maintenance going on, and they've replaced the rotor in the synchronous motor. This synchronous motor operates at 13,200 volts. The lineup of cabinets that you see right now are the synchronous motor field supply, hoist motor field supply, the accelerator control, and down at the end there's a PLC cabinet. That's where the operator has his console, all computerized, and this hoist can operate in an automatic mode. This set of cabinets is for the backup. This is the switch gear for the 3,000 horsepower synchronous motor that operates at 13,200 volts. Back up a little bit here. And that's the rotor and stator for the synchronous motor. It doesn't have the covers put on it just yet, as they've just installed the new rotor and it's not quite finished yet. The cabinets we see here are the generator field supply, synchronous motor field supply, and then an accelerator control that operate this MG set. And this is the primary control, as the other cabinets we just saw were for backup purposes. Another view of the hoist, synchronous motor underneath us here, and the electrical panels. IDS has hoists at several other locations in Peru. We have at Atacocha, which is a nearby mine, a 400 horsepower AC package operating, and another hoist with a twin 800 horsepower drive for a 1600 horsepower hoist. We're anticipating orders in the new year for a 1200 horsepower control for Buenaventura's mine at Uchuchacua, as well as a 600 horsepower service hoist replacement at Uchuchacua and a service hoist replacement at Buenaventura's Orcapampa mine. Just arriving in Peru is our equipment for a 400 horsepower hoist control going to Huaron. All these controls use AFE technology. This is a view of the hoist room at Milpo. You can see the HMIs that the operator can choose to allow this hoist to run automatically or control it himself by the master control mounted on the console. Cameras located so that they can see the position of the conveyances in the shaft, and also take a look at where the minerals being dumped, and both onto the conveyor belts and dumped into the conveyances at the bottom of the mine. AFE technology has become quite popular. Traditionally, these hoists would have used DC controls, and regeneration is required because of the way the balance is. So in the past, MG sets are inherently regenerative and were the first type of control for these hoists. And then more recently, reversing SCR controls. But the problem is DC controls produce significant harmonics and poor power factor, along with the brush maintenance that's required for the generators and the motors. So there's a lot of appeal to using the AC drives with the active front ends. An AC drive with an active front end produces virtually no harmonics and operates at about a 0.99 power factor. I'm sure this will be impossible to hear, but this is a picture of the